Dambosh Tabian. Today we have another organic compound in chapter 10, section 2. We have more classes of organic compound. We have today aldehyde and ketones. Aldehyde and ketones are organic compound which containing carbonyl group. This is the carbonyl group C double bond O, called carbonyl group. The compound which containing this group may be aldehyde or ketone. The difference between aldehyde and ketone, location of this carbonyl group. In aldehydes we have the carbonyl group in the end of chain, but in ketones we have carbonyl group within the chain. Within the longest chain we have carbonyl group in ketones. Therefore, the difference between two compounds is the location of carbonyl group. When we try to name the aldehyde and ketones, in aldehydes we have also always name of alkane. Alkane we will end it by al, alkanal, but ketone will be alkanone. Therefore, the first step to naming the aldehydes and ketone, we must assign or identify the number of carbon atoms in the chain. For example, we have some aldehydes. This aldehyde name is, we have one carbon atom in this compound, so its name will be methanol, because one carbon is methanol. This compound will be ethanol, because we have two carbon atoms. This compound will be propanol. This compound, when we name it, this is the chain, we will choose it. This is the branch which link it with the chain. In the chain we have 4 carbon atoms from the side of carbonyl group, 1, 2, 3, 4. In the third carbon we have methyl, 3 methyl, and we have butanol. There is no any number before the name of aldehyde. Before the name of aldehyde, we haven't any number in naming. Yes. For ketones, we have also chain, but we must identify the location of carbonyl group. In this chain, we have 3 carbon atoms. In the second carbon atom, we have carbonyl, so the name will be 2-propanone. Because we have a ketone. Here will be 2-butanone. Why? Because the second carbon atom will be carbonyl group. This compound will be 1, 2, 3, assigning the carbons of chain, will be 3-pentanone. Okay, in aldehydes, we haven't any location of carbonyl group because the carbonyl group become in the end of the chain, but in ketones, we must identify the location of the carbonyl group and then name the ketone. The smallest or simplest aldehyde is methanol, also called formaldehyde. And also the smallest or simplest ketone is 2-propanone and also called acetone. Okay? When we try to name this compound in chapter review, we have some questions. First, we will try to name this compound aldehyde. Question 43, 44, we have aldehydes. The first one, we have 2 carbon atoms. its name will be ethanol. Ethanol. This compound will be pentanol. Pentanol. This compound will be propanol. Propanol. According to number of carbon atoms, we have here butanol. We have 4 carbon atoms. Butanol. But when we try to draw the structure of aldehydes, we have methanol. Methanol containing 1 carbon atom. We have just 1 carbon atom in this compound. The second one, we have hexanol. Hexanol, 6 carbon atoms. Hexanol, we have 6 carbon atoms here. In the end, we have the carbonyl group because we have aldehyde. Octanol, 8 carbon atoms. 1, 2, 3, 4, 5, 6, 7, 8. We have 8 carbon atoms. In the end, we have the carbonyl group. Okay? And the other one, we have heptanol, ethanol, 2 carbon atoms. And the last one will be carbonyl group. This is the aldehydes. But for ketones, also we can name and drawing the structure of ketones. In ketones, we have the location of carbonyl group. For this compound, we have 2 propanone. This compound will be 2 butanone. This compound will be 2 pentanone, because we have 5 carbon atoms, and here we have 3 pentanone because we have 5 carbon atoms in the chain. And also when we write or draw the structure of ketones, 3 hexanol containing 6 carbon atoms, 1, 2, 3, 4, 5, 6. The third one will be carbonyl group, and then write or draw the hydrogen atoms within the carbon atoms. And here we have 2 pentanone. Pentanone, we have 5 carbon atoms. 2 pentanone, number 2, we have carbonyl group. We have 2 octanone, also octanone containing 8 carbon atoms. We have 8 carbon atoms. The second one, we have carbonyl group, 2 octanone. And the last one, we have 2 hexanone. Hexanone, 6 carbon atoms. And the second one, we have carbonyl group. The location of carbonyl group is very important in the naming and drawing structure of ketones. But in aldehyde, always the carbonyl group will comes in the end of the chain when we draw or naming the aldehydes. We have some properties about aldehydes and ketones. It is very important to assign it for wizardry questions. Note 1, we have properties and uses of aldehyde and ketones. The simplest aldehyde is methanol, also known as formaldehyde. This is the simplest one. This is aldehyde, simplest aldehyde we have, 1 carbon atoms containing, and also called formaldehyde. Formaldehyde, its use is very, very important. It was once commonly used in biology laboratories as a preservative for dead animals. Its most important commercial uses, however, in the production of the plastic, one of the first commercial plastic, bakelite. Bakelite, this type of plastic, bakelite, this plastic all coming from the formaldehyde and phenol. Phenol, this is the structure of phenol. We have benzene ring connected with OH and formaldehyde. These two substances is the main substance to producing bakelite plastic. Bakelite plastic is one of the important plastics in industrial. Was made by combining phenol and formaldehyde in large chain. The simplest ketone is 2-propanone and also called acetone. 2-propanone and called acetone. This is the simplest ketone we have. This ketone was used, whose common name is acetone. Acetone is found in some nail polish removers because it dissolves the organic substances in nail polish. However, artificial fingernails are the organic substances in nail polish. However, fingernails are made from plastics that are also dissolved by acetone. Today, other solvents are being used more frequently as nail polish removers, such as ethanol. Ethanol also can be used, or ethers can be used for removing the nail polish. Aldehyde and ketones are often responsible for acid odors and flavor. يعني طعم وبهن أو اشتشتيتن. For example, cinnamaldehyde contributes to the odor of the flavor of cinnamon. Figure 4 gives some examples of odors and flavor that come from aldehydes and ketone. We have some flavor and odors of some substances because of the aldehyde and ketone which contained in this compound. And also we have another group in this section. We have carboxylic acids. Now we will learn the carboxylic acids. Another group we have in this section, we have carboxylic acids. Carboxylic acid is very important substances which containing carboxylic group. Now we will try to name and drawing some compounds about carboxylic acids in chapter review, and we have practice to learn the drawing and naming carboxylic acids or organic acids called. Yes, we have carboxylic acids now. Carboxylic acids. This compound's general formula is RCOOH, and also can be written as follows. This is the carboxylic acid. Its functional group is carboxylic group. Carboxylic group is the functional group in carboxylic acids is COOH. This group comes in the end of the chain. Always when we write the carboxylic acid, we will see the this group or this functional group, carboxylic group, in the end of the chain. For example, we have this compound, the simplest one, containing one carbon atom, and also we have two carbon atoms in carboxylic acids, and also we have 3, 4, 5. According to number of carbon atoms in the acid, we can name the acid. Now this acid name will be methane, because containing one carbon atom, methanoic acid. And this compound containing two carbon atoms, ethanoic acid. The name of this compound will be methanoic acid. This compound will be ethanoic acid. Why? Because this compound containing one carbon atom, this compound containing two carbon atoms. According to the carbon atoms, we can name any carboxylic acids. Now we have some questions in the chapter review. We'll try to solve it to learn how does the carboxylic acid written, its structure, or naming the carboxylic acids. We have two questions about carboxylic acid, question 47 and 48. Question 47. First, we have some carboxylic acid. We try to name it. This is one of the carboxylic acids, B. Another one we have containing 5 carbon atoms. C, 1 carbon atoms containing we have. The name for this compound will be as D, cancel the D, containing 2 carboxylic group. We doesn't name it because it's not in our program in your textbook. This compound will be 1, 2, 3, 4 propan. We can say propanoic acid. Why? Because we have 3 carbon atoms. And this compound will be pentanoic acid. This compound will be methanoic because containing 1 carbon. Methanoic acid. Okay, we have another question. We will try to draw the structural formula for some acids. The acids is in question 48. We have some acids. The first one we have butanoic acid. Butanoic acid containing 4 carbon atoms. The last one will be carboxylic group in the end, in the right hand of the chain will be carboxylic acid, carboxylic group. B, we have hexanoic acid. Hexanoic acid, we have 6 carbon atoms. This is the hexanoic acid. C, also we have hexandioic acid, cancel this compound, and the last one we have heptanoic acid. Heptanoic acid. Heptanoic acid containing 7 carbon atoms. 7. In the last we have, or the end of chain, we have carboxylic group. This is the heptanoic acid structural formula, condensed structural formula. This is the carboxylic acid when we write the name and drawing the structure of carboxylic acids. Now we have some properties about carboxylic acids. It is important in Wizari and ministry questions. It's very important. The first property of carboxylic acids we have, the carboxylic acids, like inorganic acids, when dissolved in water, removing the hydrogen atom, so producing positive ion and negative part from acid. Like the inorganic acids, like HCl, HNO3, H2SO4, any acid, when dissolved in water, producing negative ion or anion with hydronium in aqueous solution. This reaction will represent this property of acid. We have this acid when dissolved in water, generally producing negative charge ion with hydronium ion. And we must know that these acids are weaker than another inorganic strong acids. That's mean when we compare this acid with another acid, inorganic acid, but with strong acid, this acid will be very weaker, very weak. Another property of this acids, we have another acid, very important acid. We have ethanoic acid containing 2 carbon atoms. Remember this acid, acetic acid, commonly called acetic acid, but IUPAC name will be ethanoic acid. Why ethanoic acid? Because containing 2 carbon atoms. According to IUPAC system will be ethanoic acid, comes from ethane. A number of carboxylic acids occur actually or naturally in plants and animals. For example, citrus fruit يعني فاقية ترش حرف فاقية ترش بتن containing citric acid. Citric acid كيف يسموه ليمون زي أبمودة هنا. This citrus acid will be present in the lemon, orange, etc. We have many fruits containing this acid. This acid called citrus acid containing 4 functional groups, containing 3 hydroxyl group as follows: 3 carboxyl group and 1 hydroxyl group. Now we will see that we have 4 carboxylic group in this acid, 1, 2, 3, and also another functional group, hydroxyl. That's mean citrus acid containing 4 functional groups, 3 carboxylic group and 1 hydroxyl group. We have 3 carboxylic group in citrus acid and 1 hydroxyl group. The total will be 4 carboxyl group. This acid, for example, ethanoic and citrus acid, are used in the food to give them the tart or acidic flavor. يعني ده طعمه كترجبة تخورني. But we have another acids, benzoic acid, propanoic acid, and sorbic acid. These acids are used in preservatives يعني مواد حافظة بجني أنجي معلبات بكاردينين. All 3 acids kill microorganisms that causes foods to spoil. يعني نوع تخورن برزت بيج بتن. يعني بجني معلبات وقت بشتت خوتي كذا بنيرة تشتاق دي داخرونه بتن one acid of carotene to as preservatives. Yes, the most widely used carboxylic acids are methanoic and ethanoic acids. We have 2 acids, is very important and many used, methanoic and ethanoic acids. These acids, because they can be made inexpensively, يعني تكلفة كيمة, they are the starting material for many chemical processes. For example, ethanoic acid is used in the production of polyvinyl acetate, PVA. PVA is very important substance, PVA, polyvinyl acetate. This compound, this polymer, comes from acetic acid as the main material used to prepare this compound. The PVA is used in latex paint. Latex paint يعني أفصل ديوارو ويا دورو ويا أصلا شو أخو بيبت قريت حشكت بتن تشكو PVA وغيرها صمغ ستركة بجني صمغ. And also used in adhesives and also used in textile coating. Textile يعني قماشي وانا داجي ام كارتين قماش مثلا رنگك صبغك علامتك تجاريه تشتغل بيفت كين جيفانا وبدا صبغه بوتشي تشكو PVA يهايتي دا جبان دي جلا مهم من اف compound دا. This compound is very important in Wizari. It must comes to say what is the main important uses of PVA. We have some multiple choices. The multiple choices will be latex paint, in latex paint, or adhesives, or textile coating. All will be the true choice. Avavin madvio am avrikavi vision. Inshallah darsobet am den esters and amine and section review am de wahmio jaragdi and wa explain inshallah darsobet buminin bkhair inshallah. خذ تعالى وهميو ناجح كتن وفيدا جلك باش جفي درس جديد بتن وبمينن بخير.